So let's just see how we can multiply two polynomials using the linked list. So first of all, let's just see how the multiplication works. So suppose we have a term 2x square and another term 3x. Now if we wanted to multiply these two polynomials, so in case of multiplication, their coefficients will be multiplied. So in this case, this will be 6 and their exponents will be added. So here this is 2 and this is 1, so they will be added, so it will be 6x cube. So this will be the result of their multiplication. So let's just see how this function will work to multiply two polynomials. So suppose we have the polynomial p1 with the term 2x square plus 3x, and we have the polynomial p2 with the term x plus 5. So previously we have seen that how can represent one polynomial using the linked list. So basically we create nodes, and inside the node, first of all we store the coefficient. So suppose we are representing this, so here the coefficient is 1, so we're gonna store 1, and the exponent is 1, so we're gonna store 1 1, and its next pointer will point to the next node. The next node is basically the second term. So the second term has the coefficient of 5 and the exponent of 0, and this, because this is the last node, so it will point to null, and the first node will be pointed by this head pointer. So this is the way we can represent the polynomial using the linked list. So here in the function, it is taking two polynomial p1 and p2. So first of all, we have created the result list, so this will hold the result of the multiplication of those two polynomials. Now in the function, we are using two nested loops. Now in the outer loop, we are using the temp1, so the temp1 is pointing to this polynomial p1. So we're gonna use this to traverse the p1. So in each iteration, it will just basically shift to the next node in the list. And then we are creating this temporary result. So we are creating one temporary result which will store the result after one multiplication. And then in the inner loop, we are traversing this polynomial p2 using the temporary pointer t2. So the loop will continue as long as the temporary pointer is not null, and in each iteration the pointer will be shifted to the next node. So first of all, the temporary pointer t2 is pointing to x and t1 pointing to 2x square. So that means here we're gonna perform the multiplication. So here we're gonna multiply temp1 coefficient, mean this coefficient, with the temp2 coefficient, mean this coefficient, that here we have 1. So we're gonna multiply them, and also we're gonna add their exponent, because in case of multiplication the exponents will be added. So here this 2 will be added to the 1. So we're gonna put the result in the temporary result. So this multiplication result will be stored in this temp result. So it will be 2x cube. Then in the next iteration, the temp pointer 2 will be shifted to the next node. That means it will be shifted to the next node, second term. Now we have to multiply these two terms. So here the coefficients will be multiplied, so this will be 10x square, and the result of their multiplication will be stored in the temp result. That means it will be stored right here. Now after the inner loop ends, then the temp result will be added with the result. That means this temp result will be added to this result. So add polynomial, we have talked about this function earlier. So this add polynomial function basically takes two polynomial, and then it checks if the exponent of p1 is greater than the p2. In that case, it will take the coefficient and exponent of the p1 or polynomial 1. Otherwise, if the p2's exponent is greater than the p1's exponent, in that case we're gonna take the coefficient and the exponent of the p2. Otherwise, when their exponents are equal, then we're gonna add their coefficients, and also we're gonna take their exponent, and we're gonna create a new node of that coefficient and exponent, and then we're gonna add that to the result. And after the end of this whole iteration, we're gonna return the result, which is the addition of both of the polynomial p1 and p2. So this is how the add polynomial is working. So because here the result initially was empty, so the whole thing will be added to the result. That means the 2x cubed plus 10x square will be added to this result. And then in the next iteration we're gonna reassign null to the temp result. That means this will be null, so it will be emptied, and it is ready for the next loop of multiplication. So here the temporary pointer t1 is shifted to the next node. That means it will point to the next term, and the t2 will start from the beginning again. So that means we're going to multiply these two terms. So here the result will be, so we're going to multiply the coefficient, so it will be 3x, and the exponents will be added, so it will be x square. Similarly again the t2 will be shifted to the next node, and now we're going to multiply these two terms, 15 and then x, and after that we're going to add the temporary result to our result list. That means this will be added to this one. So again we're going to call this add polynomial, which will add those two polynomials. That means their exponents will be compared. If they match, then only we're going to add their coefficient. So that means here these two terms will be added. So the final result will be 2x cubed plus these two terms will be added, so it will be 13x square and then 15x. So this will be the result after multiplication of these two polynomials. And after the end of the function we're going to return this result. So here we can check that. So let's now create the polynomial p1. So we're going to insert the term using the insert term function. So the first term in the p1 we have the coefficient 2 and the exponent 2. We're going to pass 2 to. And in the second term we have the coefficient 3 and exponent 1. So it will be 3, 1. Similarly we can create the polynomial p2. So we're going to insert the term. So the first term contains the coefficient 1 and the exponent 1. So we're going to pass 1, 1. And the second term contains the coefficient 5 and exponent 0. So we're going to pass 5, 0. So our two polynomials are ready, and also we have the multiplication function. So let's just multiply them. So we're going to call the function multiply polynomial, and we're going to pass the polynomial p1 and p2. Now this will return the result after the multiplication. Now first of all we're going to print the polynomial using the print polynomial function, and we're going to print the p1, and then we're going to print the p2, and after that we can print the result of their multiplication. So here we have the polynomial 2x square plus 3. This is the first polynomial, and then x plus 5, which is the second polynomial, and their multiplication is, so this is the result, which is 2x cubed plus 13x square. So 2x cubed plus 13x square and then 15x. So here we have the 15x. So that means we have successfully multiplied two polynomials using a function. So hope you understand about the multiplication of two polynomials using the linked list. So hope you understand the concept. See you in the next one. Take care.